Okay, these are notes for section 4.9, and this is one of the problem types, and I'll just call it the painting plus the frame equals the total. And the problems are all the same. It could be a swimming pool with a deck or a park surrounded by a walkway, but it is a problem where you have something on the inside, a border around the outside, so you're calculating the area of the total. And in this particular problem, an oil painting is 10 inches longer than it is wide. It is bordered on all sides by a 3-inch frame. The area of the frame alone is 402 square inches. Find the dimensions of the painting. So look at the sketch and let's mark up our dimensions. So going to the inside, the painting is 10 inches longer than it is wide. So I can let this be my width. And then width plus 10 on the side for my painting, my Mona Lisa painting. And then the frame itself is 3 inches wide all the way around on all 4 sides of the painting, a 3-inch frame. The area of the frame alone, which is your wood grain on your handout, and I'll make it green here. Just this green area alone is the number 402. And then what I need to determine, or what I need to now figure out, is how to represent the area of the entire painting. So if I had to hang this somewhere in my home, how much wall space would I need to set aside to hang the entire painting, framed painting? And the way you determine this, I have the blue W in the middle for the width. And I have added 3 inches on one side plus 3 inches on the other side. So that means this total dimension here is now W plus 6. And then the vertical dimension, well, I had a W plus 10 for the painting, and I've added the 3-inch frame, or the 3-inch frame to both vertical dimensions, both top and bottom. So that means my entire vertical dimension is really W plus 16. The 10 that I started with in the middle, right here, W plus 10, and then the 3-inch frame on top, 3-inch frame on bottom, giving me the W plus 16. And then you look at the verbal equation. So each equation you need to write a verbal description of what's happening. So the area of the painting plus the area of the frame equals the total. The area of the painting is represented by W times W plus 10. The area of the frame is given in the problem. The area of the frame is 402 square inches, so just 402. And then the dimensions of the total framed piece are W plus 6 times W plus 16. So read the problem, mark up your sketch, express the entire dimension, and then write a verbal equation and make algebraic substitutions into your verbal equation. Now you need to use your new skills with distributing, multiplying polynomials together and using properties of exponents whenever you multiply variables. So now it's time to simplify this to solve for W. And then here, multiplying my binomial pairs, I end up with 22W plus 96. And then, for now, the powers to the second will subtract out on both sides. Isolate the W, so if I subtract 96, then I end up with 306. And then if I subtract 10W, I end up with 12W. Multiply by 1/12 or divide by 12, and I get 25.5 for the width. So take a second, understand the algebra behind this. I'm going to erase the board, and then we're going to wrap up the problem with finding the dimensions of the painting. Well, actually, we can just use what I've got here. So W is 25.5. and the other dimension would be 35.5. So to answer the problem, the dimensions of the painting, it's a 25.5 by 35.5. The second problem is the same type. Now the painting is 3 inches longer than it is wide, so same thing. One dimension is W, the other is W plus 3. The frame in this picture is 2 inches all the way around. So then my total dimension would be, my horizontal dimension would be the red W in the center plus 2, or W plus 4. And then my vertical dimension would be the W plus 3 in the center plus 2 on top and 2 on bottom, so 3 plus 4, or W plus 7. And then your verbal description, the area of the painting represented by W times W plus 3. The area of the frame, we're told, is 100. And then the total dimensions are W plus 4 times W plus 7. And then it's exactly like the other problem. And as always, for now at least, the terms to the second power will subtract away, and then you're simply left with subtracting 28 from both sides, and then subtracting 3W, and then I'm left with this. Multiply by 1/8. So the dimensions of the painting, W is 9, and W plus 3 is 12. So the painting here is a 9 by 12.